Okay, so as we planned, we are going to do the chapter 1, and the chapter 1 is on the scientific method. Okay, and everybody know that the textbook is Physical Universe by Croscom, and you could buy any edition book as long as you follow the scientific method title, okay? And this chapter we are going to deal with actually what is science. Anybody knows what is science? Science? Okay, science is something that it is a process. It tells you how something is originated, how something turns into something else, and why something has a different color, or something has, does only in this fashion, or something changes in certain fashion. All those things, a process, whatever is discussed is called a science. But science is not like a fact, something like we all know that sun rises in the east, or some world war happened at certain time. So those kind of facts are not science. Science is only process, and it always asks you, it will always address somebody asking questions and answering questions. So science is, you don't have to write anything which is projected right here, because you already have everything on blackboard, all the slides. But if I write something here, maybe if you want to, you can write something down here, but this one you already have it, okay? Science is a process, and it always, yes, you have questions? So it always asks questions, and it always answers the questions too. And science is not a collection of facts. When I say science is not a collection of facts, it is telling me that it is not all the facts, such as the art or a painting or all those things. You have something here? Okay. All right. So science is not a collection of facts. It's only a process which kind of asking questions and trying to answer all those questions. So science always deals with naturally happening things. So if something like we have a leaf, we know that it's in green color. So if somebody explores why it is in green color, that is science. Something like that, okay? So we are just observing the natural things and trying to figure out why those things are in that way. And by observing that, we try to reproduce the same thing. Something like, we know that sun is hot. So if we observe, or if we find a way to find out how the sun is hot, we can just mimic the same thing and make something like a heater or some kind of things to make our selves a little bit hotter or something like that. So natural happening things, we try to understand them, and we try to mimic them and make tiny objects to make our lives a little bit simpler or more luxurious. That is about science. And just natural things, we try to observe and find a way to mimic them. And there are two kinds of sciences. One is life science, which is the science on the living things. So example is biology, zoology, which does the experiments or which studies on the living organisms. And physical science, which is the non-living things. So do you think the physics come under the physical science or the life science? Non-living, right? Physics is something like we don't talk about we talk about force and energy and all those things, but we don't talk about, those are kind of non-living things. Those are imaginary or feelable things, but not really like a touchable thing, okay? So if it is something touchable and if you can see it, it has a life, which is life science. It doesn't have life, but it acts. It has some impact. That is the non-living science, and which is classified as physical science. So anytime, of course, we know that whoever does some kind of experiments and try to read things, we all call them scientists, right? So they all follow certain procedure to draw some conclusions or find out some things. And what kind of procedure they follow is, they follow these 4 steps right here. First one is they formulate the problem. So something like we all know that the sky is blue, right? So somebody must have thought why the sky is blue instead of red or orange or whatever the other colors. So formulating a question. So somebody asks themselves why the sky is blue, something like formulating a problem and observing and experiment. So we're going to observe something like, is it blue all the time or sometime? and what makes it blue by doing some experiment. So if you want to have something in blue color, then what you should do, keep on doing some sort of experiments, and then, but excuse me, based on those results, you interpret. So you try to, just make some sense out of whatever the experiment you do or whatever the observations you do, and you make a hypothesis. Anybody knows what is hypothesis? Very good. Educated guess or question. Instead of question, some kind of an answering is a hypothesis. Okay, so hypothesis is that you are trying to explain, but uneducated, not like a lame person or without any background or without any kind of backup. So if you have some kind of backup and something like an educated does backup makes support whatever the statement you make, you have some kind of educational support to back up your statement. So you make an interpretation, and finally you test your interpretation whether it is working all the time or sometimes, and then you draw the conclusion. If it doesn't work, then again you're going to go back to the observation and experiment and again interpret and then again draw conclusions. So you keep on doing the same things until you answer this question which is raised. So this is the scientific process. Scientific process has 4 things. One is ask a question, observe and experiment, interpret, finally you draw conclusions. So these are the 4 steps all the scientists follow in order to answer any sort of questions. So the same thing is given in flowchart, which is what is the question being asked, then experiment, you collect the data and based on the problem, and then you do the interpretation, draw conclusion. If the conclusions are not really satisfactory, then again you're going to go back and you keep on doing it until you get the satisfying answers. Okay? What is hypothesis? We already discussed. Hypothesis is nothing but an educated guess that can be tested. Okay, so you could do some experiment or something like that, and based on based on whatever the guess you make, you could test it. That is called hypothesis. And observation and experiment. So these are, I'm sure you all know these words, but probably you might get confused with those things. That's why we are giving the definitions, exact definitions of each term, something like hypothesis, and then observation. So what is the difference between an observation and experiment? Observation is you simply look at it and try to see things, but experiment is something like you make something or you do something or you make a smaller object or whatever you're doing and try to do some experiment. That is the experimentation. So in here you have some data collection, you draw some conclusions and so on and so forth. Here also you draw conclusions, but you may not do some physical experiment of moving things, adding things. Those things you might not do in observation. You simply look at things and see if it if it's making any sense or not. Observation can be done without an actual experiment, and experimentation is nothing but a careful observation that might require recording the information, and something like the experiment is simply manipulating the nature, then observing the results. Something like if you want to find out the Earth's weight, how much is the mass of the Earth if you want to do it. Can anybody make a scale and put the Earth on it and make the find out the weight, mass of it? No, right? It's not nearly possible. So what we have to do is we make a mimic of Earth is globe, right? The small tiny globe. So they try to make it and they try to find, use all the physical phenomena and try to find out the mass of the Earth. So that kind of thing. So experiment is nothing but manipulating the nature, and trying to observe the results is experimentation. Then laws of nature. So we all know that there is like Newton's law, Kepler's law. We all see some kind of laws. So what is the difference between a law or like simple statement? So that's what is given in here. Represents our current best understanding. So far, this is what is the best, or this is what is valid point. So nobody came and said something like, we all know that apple falls from top to bottom, right? Like it often always falls down. We all know that, right? So till now, we all accept that Newton said apple always falls down, not goes up until, if anything goes up, it has to fall down. So that is what we believe in. So until some other scientist comes up and says, Okay, no. So this is just an accidental thing, maybe a million times it happened, but this is not going to happen anymore. So if somebody comes and says that a contradictory statement that actually this is not valid until that time, these laws are valid. Okay, laws could be changed, but this is our current best understanding is the law. That's the best understanding so far is the law, but it could be changed over time though. So there's nothing that, it is the fixed forever. And subject to change based on the additional observations, so this could be changed. And when we say apple falls down, it will fall down whether it's US or Jamaica or India or China. So it should be applicable anywhere in the universe. So if we say it is a law, this law is applicable everywhere in the universe. If it is the tiniest particle or the hugest particle. So if it's law, then it has to be applicable to everything, anything in the universe. From atom to galaxies, the tiniest to the biggest. And then it could be used to predict unknown phenomena. Something like, we talked about, finding the mass of the earth, or we all know that sun is a too hot thing to go nearby. But we know that the temperature at the sun is about 7,000 degrees Kelvin. But how did we make that guess? Based on these laws, we try to predict the unknown or the unreachable things, properties. It allows us to understand what occurs in places where we cannot examine directly. Something like, we cannot go to sun, but based on these laws, we can find out what might be going over there, something like that. And theories and models, law always tells us what it is, theory is why it is. So that is the difference between law and theory. Law just tells you what it is, and then theory tells you why. The sense behind it is the theory. Theory is more than a hypothesis. So the difference between theory and hypothesis is, hypothesis can be tested. It means it is not tested yet. But the theory is already tested and proven is a theory. Okay? And the fully developed logical structure is a theory, and based on well-understanding, theory is based on well-understanding and general principles. So based on these two, a fully developed or sensible thing is a theory. And hypothesis we already talked about. And model is a simplified version of reality. So we say we are making a model of it. It makes a simplified version of the bigger things. Something like example, Earth is a sphere. So we always make, whenever we talk about Earth, we make a small sphere and we say, okay, this is the Earth and this is rotating like that, or so on and so forth. We talk about things like that. And then why is science successful? We all know that, science is always fascinating, right? So why science is fascinating? Because maybe about 10 years back, everybody used to have big gadgets, or let's talk about this one, the computers. So everybody had only computers, they didn't have laptops. So scientists didn't think that, okay, these computers came and we don't have to do anything. They didn't sit quiet and they didn't think that this is enough. But people thought that no, the computers are too big and too heavy, they are not mobile. And then they thought about the laptops. And we know that the laptops were too big, and right now they are mailable size. So we can get everything done in a smallest and tiny, lightest weight. So this is what it is, that science is not frozen, the knowledge is not frozen. We constantly add things to that. That way it just makes us so fascinating. So we used to have big particles, then now the nanoparticles. So we try to make it the smallest and lightest things. That way people always get so excited, and that's why the science is so successful. Everybody wants to go into sciences, whether it's science or engineering is the same thing. Engineering is making a device on top of it, on top of the understanding of science. But science is the basic thing that without it, nothing can survive, something like that. Scientists question previous results, so they always think that, well, why this is only it? It has to be better than that, so something like that. So they question the previous things, and they try to improve it. And that's how this is not a frozen thing. It keeps on adding things every day. And common sense is not a valid argument, so we cannot call common sense as a science. So if we answer some things by, okay, it's common sense, so that's not science. Okay, so that is, if something can be explained by common sense, that's not classified as science. and survey of the sky, and